first model that we implemented was a standard k-means cluster. We chose a subset of demographic attributes and performance attributes to include in the model to determine which attributes are strongly related in the population. We elected to use the raw counts of each attribute as opposed to the percentage value and proceeded to cluster using these records, which consist of main offensive metrics in basketball as well as key defensive and player characteristics. For example, player height is important when considering the player's position that are present in each cluster. We tested K values between 2 and 5. A K value of 3 was initially particularly interesting as we assigned players into 3 main categories of position: centers, forwards, and guards. And we're curious to see if the clusters formed would reflect the roles of the different player position. The 2-cluster model had the lowest Davies-Bouldin index, while the k=5 model had the highest. With this data set, there may be useful insights to be drawn from many cluster models indexed at less than 1, especially if more layered data is incorporated. The effects of team performance or subdividing player positions into more groups may offer insights into those player groups. We tested other cluster models as well. There are a large number of nested clusters and a hierarchical clustering, which we flattened and reviewed with similar values of K. A group de novo cluster model showed us that we can be 95% confident that, on average, the clusters had different means and were not overly similar. These models all help to separate NBA players and determine different groupings of players based on performance attributes. This data and modeling can be used by analysts to inform coaching on what their top players are doing well and what separates those players from the rest of the competition. The use of these metrics has increased in recent years across all professional sports for a number of reasons. New scientific approaches to performance and increased viewership, as well as demand for player analysis, are very prominent in modern times. Consider the scatter plot pictured here. This is the k=5 cluster model, which does not have the lowest Davies-Bouldin index score. However, we can see that the clusters are pronounced when we examine the offensive attribute points and the defensive attribute blocks, as well as player height. This cluster can tell us which players are offensively strong, defensively strong, and players with more neutral skills, as well as the player's position. Similar insights can be gleaned to outline and understand player roles on the team, when they should be brought in as substitutes, or which players will complement each other on the court. We believe that the centroids found in the initial k-means are reasonable, and that the clustering players based on their individual performance can be helpful in understanding what attributes different subsets of NBA players share. Increasing the value of K may continue to offer insights while the Davies-Bouldin index is less than 1. This is because different player attributes can stand out as we group different players together. This will continue to provide insights into which groups of players are performing well and can highlight which players can be substituted into areas to level out skill gaps.